In this video, we want to look at derivative of a function of a function. If, for example, we have that y is equal to sine 2x minus 3. Now, what we need to understand is that y is a function of the angle 2x minus 3, which is in itself a function of x. Because of that, we will say that y is a function of a function of x. And we can use, if we want to solve this question, we can use chain rule to solve it. So let's differentiate it now. So let's say differentiate y equal to this. What we're going to have is that we can say let u be equal to 2x minus 3. So if we want to rewrite this thing, we can say that y is equal to sine u. Now we can differentiate this u with respect to x. So if we differentiate u with respect to x, du dx, we're going to have 2. If we differentiate this, we'll have 2. Therefore, if we now differentiate y, differentiating y with respect to u, we're going to have, if we differentiate this, we'll have cos, we bring down u, because if you differentiate sine, you have cos. So if we now want to find dy dx, it will now be equal to dy du times du dx. This is because du can still cancel du to have dy dx, so which is equal to dy dx. Now, what is our dy du? Cos u times our du dx 2. We can now unsubstitute this and introduce u, the value of u. So dy dx is equal to cos, instead of u, we say 2x minus 3 times 2. So the final answer is now going to be 2 cos, that's 2 multiplying this, 2 cos 2x minus 3. That is the answer. So in the same vein, let's look at another question. This says, if y is equal to tan 4x plus 1, find dy dx. The same way, we can say, let u be equal to 4x plus 1. Therefore, if we differentiate u with respect to x, we're going to have 4. The equation can be rewritten as y is equal to tan u. So that if we differentiate y with respect to u, we're going to have sec square u. Because when you differentiate tan, you get sec square. Therefore, we can now say that dy dx is equal to dy du dot du dx. So that's dy dx. Therefore, we have dy du to be sec square u times, we have du dx to be 4. So if we multiply that, we have that dy dx is equal to 4 sec square u. We can now reintroduce u into it. We can now say that dy dx is equal to 4 sec square. Instead of u now, the value of u is 4x plus 1. In the same way, let's look at this question. It says, if y is equal to exponential 5x, find dy dx. Now, we can say let u be equal to 5x. So we can rewrite this equation as y is equal to e raised to power u. If we differentiate u with respect to x, we're going to have 5. Now, if we differentiate y with respect to x, with respect to u, sorry, so we'll still get eu, because the derivative of exponential is still exponential. Therefore, dy dx is equal to dy du times du dx, so that dy du is eu dot du dx is 5. So we can say that dy dx is equal to 5 exponential. Instead of writing u now, we replace it again with 5x. So that is the answer. In the same vein, let's solve this. If y is equal to e exponential raised to the power 3x plus 4, find dy dx. Feel free to pause the video and try it out yourself, the same way we tried the last one. We can rewrite this equation and say that let u be equal to 3x plus 4, so that our equation can be y is equal to e raised to power u. Now, if we differentiate u with respect to x, we're going to have 3. Because if you differentiate a constant, you get 0. We're going to have 3. And if we differentiate y with respect to u, we're still going to have eu. That is this. We're going to have eu. Now, we can now say that dy dx is equal to dy du times du dx. So that we will have that dy du is e raised to power u times du dx is 3. So if we multiply, we'll get that dy dx is 3eu. So instead of u, we replace it with a value which is 3x plus 4. In the same way, let's also solve this. If we have that y is equal to cos 2x minus 1, find dy dx. We can say let u be equal to 2x minus 1, so that the whole equation can be rewritten as y is equal to cos u. So if we differentiate u with respect to x, we're going to have 2. And if we differentiate y with respect to u, we're going to have minus sine u, because if we differentiate cos, we'll get minus sine. If we differentiate sine, we get cos. So if we now want to get our dy dx, it will be dy du times du dx, which is equal to, our dy du is negative sine u times our du dx is 2. So if we multiply that, we're going to have minus dy dx is minus 2 sine u. Instead of u, we replace it as 2x minus 1. Feel free to like this video and subscribe if you have not subscribed to our channel yet, and also feel free to share it to your friends.